So this video is just to give you a brief overview of some of the stuff you're going to see in Chapter 8. So Chapter 8 deals with integration and various ways of doing that. So this will go through a few examples of some of those. So let's say I want to integrate x plus 2 over x squared plus 4. Well, I can break this out into pieces, x over x squared plus 4 dx plus the integral 2 over squared plus 4 dx. Okay. So my first integral, I could do some substitution, let u equal x squared plus 4, and then du is going to be 2x dx. And so I'm going to get 1/2 integral du over u, which would be 1/2 ln u, which would be 1/2 ln x squared plus 4. Okay. So let's now go to the other part of this. And so we could have, well, this is going to be 2 the integral dx squared plus 4. And then we could say, do again some more substitutions here. So u is going to equal x over 2. And then du dx equals 1/2, and then du equals equals 1/2 dx, or dx equals 2 du. Okay. And so this will give us so we get 2 times 1/2 integral 1 over, oh, sorry, I skipped this up. Sorry, let me go back. And, sorry, let's go back a bit. Skip the line. All right. And so we're going to make some substitutions here. This is going to give me 2 over 4u squared plus 4 du. So this will be 2 times 1/2 1 over u squared plus 1 du. And so we have 1/2 natural log of x squared plus 4 plus, and this form ends up being arctangent x over 2 plus c. Well, let's go through another example. And so now we have this one. Integrate 4 to 2 x squared plus 2 over x plus 1, or sorry, x minus 1. X minus 1. So this one we're going to first do some dividing here in terms of this rational function we got. So let's see, what do I got to multiply x by to get x squared? Well, that's going to be x. So this is going to give me x squared minus x. Next step is to subtract. And so we get an x plus 2. And then we got to multiply x by to get x. Well, that's going to be 1. So this is going to give me an x minus 1. Again, then we subtract. and we get a remainder here of 3. So we have our remainder. Right? So now what we can integrate this is this is going to be integral of 2 to 4 x plus 1 dx plus the integral 2 to 4 3 over x minus 1 dx. And so this will be x squared over 2 plus x, evaluated from 2 to 4. So this is going to be 4 squared over 2 plus 4 minus 2 squared over 2 plus 2. And let's see, 4 squared is 16. 16 over 2 is 8. So this is going to be 8 plus 4. So this is going to give me 12. 2 squared is 4. 4 over 2 is 2. So this is 2 plus 2. So this is going to be 12 minus 4. And this part is going to give me 8. And now let's go to the back part of this. And so we have here, this can be the integral of 2 to 4. Bring the 3 out front. Dx over x minus 1. And we could have, well, u is going to equal x minus 1, and du is just going to be dx. So we get 3 times the integral 2 to 4 of du over u, which is going to be 3 ln of u, which is x minus 1, evaluated from 2 to 4. Okay. And so this part gives me 3 ln 4 minus 1 minus ln 2 minus 1. So this is going to be 3 ln 3. ln 2 minus 1 is 1, and the natural log of 1 is 0. And so we're left with 8 plus 3 natural log of 3 in terms of that one. Other methods they mention here is integration by parts. So integration by parts, you have u dv is going to be u times v minus the integral of v du. So let's do an example here first. X e to the x. So Billy, you need to figure out what is the u and what's the v. And Billy, you want the u to be that thing that's going to give you the easiest derivative. So u is going to be x, and then the derivative of that is just going to be 1. And then v, dv, is going to be my e to the x. And then if I integrate that, I get e to the x. So now if I plug this in, I get x e to the x minus the integral of e to the x times 1. So this is going to be x e to the x minus e to the x. And then we get our plus c. Okay. So let's do another one. So let's do this one. So we're going to have integral x squared ln x. And again, we want to pick the thing that's going to work out to give us the easiest thing. And so again, you can try it, and then if it works out, you're going down the wrong path, you can always try it the other way. So let's say u, now this case is going to be ln x, and then dv is going to be x squared, and so du is going to be 1 over x, and v is going to be x cubed over 3. So now if I plug this in, we're going to get the natural log of x times x cubed over 3 minus the integral x cubed over 3 times 1 over x dx. And let's rewrite this the other way now. This will simplify to x squared over 3 dx. And so we get x cubed over 3 ln x minus 1/3 the integral of x squared dx. So x cubed over 3 ln x minus 1/3 x cubed over 3 plus c. And we end up with x cubed over 3 ln x minus x cubed over 9 plus c. For that one, all right? Other integrals they talk about in this chapter, they talk about trig integrals. So let's do an example of one of those types. So if I have this, cosine to the 5th x dx. And so if you remember your identities, your trig identities, one of those was that sine squared plus cosine squared equals 1. So cosine squared is 1 minus sine squared. And so we could first factor this out. So we get cosine to the 4th x times cosine x dx. And then we get integral. This will be 1 minus sine squared x squared cosine x dx. And then u, and actually let's do this in a different color. So now we can do substitution. And so it's u equal to sine x. And then the derivative will be cosine x. And so now we can substitute. And so we get the integral 1 minus u squared du. And so this would be 1 minus 2u squared plus u to the 4th du. And then if we integrate this, this will be u minus 2u cubed over 3 plus u to the 5th over 5 plus c. And then the last step is to substitute. So we get sine x minus 2 sine cubed x over 3 plus sine to the 5th x over 5 plus c. And so we get that. Another method they do, and here is method using partial fractions. So now we have only this. F of x equals x minus 2 over. If I look at the bottom part, we see we can do some factoring here. So we could first start by taking an x out, which gives me x squared minus x minus 2. But then that can be factored to be x minus 2 and x plus 1. Right? So now we could take what we had, which was 3x squared plus 7x minus 2 over the x times x minus 2 times x plus 1 is going to be equal to a over x plus b over x minus 2 plus c over x plus 1. So what we want to do now is be able to figure out the a, the b, and the c. Right? So that would mean that 3x squared plus 7x minus 2 is going to equal a times x minus 2x plus 1 plus b times x plus 1 plus c times the x minus 2. Right? And so this would be a times x squared minus x minus 2 plus b times x squared plus b plus c times x squared minus 2. And so we get ax squared minus ax minus 2a plus bx squared plus b times x squared. This should be an x, sorry. Let me correct that. This should be an x. There we go. Bx squared plus bx. And this should be x squared. This should be minus 2x. Plus cx squared minus 2cx. All right. So we get that. All right. So now we want to first look at my x squared terms. So we have one here. We have one here. And we have one here. So what that tells me then is that a plus b plus c has to equal 3, which is the number in front of my x squared term. Then we're going to go to my x terms. So we have one here, minus there. We have one here, and we have one there. Okay? So we have a minus a plus b minus 2c has to equal 7. Right? And then let's see, constant terms. We have just that one. And so we have a minus 2a is going to equal a minus 2. So now we need to solve these and get our a, the b, the c. So let's start with the bottom one first. So minus 2a equals minus 2. And so a is going to equal 1. So we know what a is. So now we can have, okay, so now that we know what a is, so 1 plus b plus c equals 3. So that means that b plus c has to equal 2. And then we got a minus 1 plus b minus 2c equals 7. So b minus 2c has to equal 8. So now we got two equations, two unknowns. Right? And so we have b minus 2c equals 8. B plus c equals 2. So if I leave this one alone, multiply this one by 2. So we have b minus 2c equals 8. 2b plus 2c equals 4. So this will give me 3b equals 12. And then we divide by 3. And we end up here that b is 4. And so if we know what b is 4, and we had that b plus c was equal to 2, so 4 plus c equals 2, so c has to be negative 2. So we have our values for a, b, and c. Right? So now if we integrate, so we integrate this, So we have 3x squared plus 7x minus 2 over the x minus x squared minus 2x is the same thing as integrating our a, which we said was going to be 1, right? So this is going to be the same as 1 over dx plus integrating 4 over the x minus 2 plus integrating minus 2 over the x plus 1. Right? So that'd be 1, the integral of dx over x, plus 4, the integral dx over x minus 2, plus a minus 2, the integral dx over x plus 1. And so this will give me the natural log of x plus 4 ln x minus 2 minus 2 ln x plus 1 plus c. Right? And that will conclude this brief overview of the chapter.